Good morning, students. I am Dr. V. Chandra Jagan Mohan from the Institute of Aeronautical Engineering. So today we are going to discuss about the subject wind and solar energy systems. See, everybody knows today the wind power and solar power. These are extremely emerging very fastly. These energies are replacing the conventional energies. See, first of all, we need power. We need to generate more and more power day by day. So the demand of electricity is increasing day by day. So because of so many reasons. So if you go to the industrial load, if you go to the domestic load, if you go to the commercial load, if you go to the agricultural load, see, all these types of loads are increasing day by day. See, we have to meet the demand. So there is a big gap between the demand, between the necessity and our generation and supply. Only the country where there is a surplus availability of electrical power. So we people know that everything has changed into the electric field. So in olden days, we used to run an industry with the help of the coal. We used to run a train with the help of the coal. We used to cook with the help of the wood. So all these things are replaced with electricity. And because of the technology, so many things like if you go to the domestic, so earlier we don't have televisions, fridge, AC, all these things. So the electricity is the kind of energy where we can convert it into any type of energy. We can convert electricity into any type of energy, and any type of energy can be converted into electricity. So that is the advantage of the electric power. So because of these reasons, so why we have replaced these traditional systems where we are using the coal, all these things, the electricity is that. So if you use electricity, it's neat. So if you are running the bike, so nowadays it's a huge shift. The automobile is shifting towards the electrification. So that is that. So it is environmental. In the version of environment, it is clean energy. It is neat. And also because of huge demand of oil and gas. So for the country like India, see, we are importing so much of oil and gas. So we are in the top position on importing. So this is a real burden to the country's economy. So majority, almost we are spending on the import of the oil and gas. So, so that's the reason why the governments, anyway, they started searching for alternate ways of producing or running without the use of oil and gas, and also, of course, coal. So if you come to the methods, we can, the ways we can generate power are actually so many new types of innovations are coming, even without wasting a small energy also into electrical energy, and they can be stored. So even though there are newly emerging electrical technologies for generating the power, so we can mainly say we can divide, we can bifurcate this type of electrical power generations majorly into two types. So that is conventional and non-conventional, or otherwise we can say renewable and non-renewable energy sources. So if you non-renewable energy sources, there is plenty availability. So most of the non-conventional sources are renewable sources. Almost conventional sources are non-renewable sources. So we have started with using, so because of the necessity in European countries, necessity of industrial revolution. So they started with steam engine. So where there is a scarcity of manpower, they started with the steam engine. So they used to run a factory or run a rail with the help of a steam engine. So afterwards, we have replaced it with the electrical energy. So most of the energy, most of the power today we are getting with the conventional source, that is the non-renewable source, that is the thermal power. In the thermal power, that is majority is from the coal. So we are going to use different types of coals based on its calorific value. Bituminous, lignite, like this. Different types of coals. So its value depends on the calorific value it is having and its cost. So we are going to, based on the cost, based on the transportation, all these things, its caloric value, we'll decide which type of coal we have to use in the thermal stations. So even today, in any country, in the world, the majority of the power demand, we are meeting with the help of the thermal energy, that is the coal power. So, which is the non-renewable source and a conventional source. So, it produces so much pollution to the environment. So, we are already in a risk of global warming. So that was the first major source. And in that we will get the nuclear power and from the gas turbines, diesel, all these things, all these categories. So energy from the waste, all these things comes under the basically from the thermal energy. So where the thermal energy, we are going to burn something, some fuel is needed there. Maybe coal or something else, gas or oil. So that energy, the heat energy, we are going to use to rotate the turbine, and which rotates the generator, shaft of the generator. So where we are going to get the electrical output. So that is the major case. The next thing which we were using traditionally, conventionally, is that the hydropower. So this is the cheapest source of conventional source, non-renewable source, conventional source, where but the installation cost is very high. So these are the sources we were using to generate the power, majority of sources which comes under the convention. If you come to the non-conventional or renewable sources, so we are having different renewable sources like wind energy. So we have very world practice with this wind energy. We don't know, but the wind, we are using this wind energy. So wind, okay, the air with energy, with potential, the air with potential is called wind. So we are using this potential of air, the moving air, we are calling it as the wind because it has power, some force. So we were the utilization of the potential of the wind or wind energy is a very world practice where we were using this wind energy to sail the ships in olden days, to grind for grinding purpose, for pumping of water. So this is a old practice. So that was old practice where we were limited to use it for sailing the ships or grinding of grains or for pumping of water. Next, in the renewable sources of energy, so that is solar energy. If you come to the solar energy, there is the entire solar system. The life itself is based on the solar energy, is dependent on the sun. So whatever you are saying, the wind energy, the hydro power, so these are indirectly dependent on the solar energy. So in this solar energy, we are having so much of potential. If you observe the energy, the availability of resources can turn a poor country into a rich country, a desert into a rich country. The example are the Gulf countries. So before they were using the oil for our uses, before the oil is found there, so those countries were very poor. Similarly, the countries now with so much of wind potential, the countries now with so much of solar potential can become. If you observe in India itself, the Gujarat and Rajasthan, so where we are having so much of solar potential, the lands which were not at all useful has become very important, has gained their importance because of this solar energy installations, because of this wind power installations, power plants. So that is the power of both way. We can use that wind, and those areas which were remote, which were not at all useful, which are very cheap, which are poor, will gain the importance. So that is the specialty. So if you afterwards we are having different things in non-conventional energies or renewable energies, that is wave energy, tidal energy. So this wave energy and tidal energy have not reached to the commercial point. They are still there is so much of research had to be done. Innovation had to be taken place to become famous or to become economical. So this subject only we are going to discuss about. So these renewable and non-renewable sources will come under the generation of electrical power. So in that renewable sources of energy, we are going to only discuss mainly about the wind. We are going to concentrate on the wind and solar energy. So this wind and solar energy have almost replaced the hydropower in reached to the capacity equal to the power which we are producing with the help of hydropower. So, and government still wants to increase this production of wind energy and solar energy, wind energy and solar energy. So, first we'll move to the wind energy. Here we will discuss about the how we have to capture. So we were using this wind turbine since from the ancient time, but not for producing the power or generating the electricity. So, if you want to capture wind power, you need a wind turbine or a windmill. So, olden days we used to call it as windmill, and now technically we will call it as wind turbine. So, turbine is the thing which is converting that potential of the wind into the electrical power. So first, for generating power with the help of the wind, we need a turbine, and we have to keep this turbine in the terrains, in the places, in the areas, in the lands, offshore or onshore, where there is much availability of the wind throughout the year. We have to take the history of the winds in that particular area. And the wind speeds, the history of the wind speeds of that areas, and we have to decide which type of wind turbines we have to install there to get more commercial, more economical output. So first we have to select the land or select the place, and afterwards we are going to install the plant there, wind turbines. So if you look at the wind turbine roughly, so we'll see what are the parts. In simple way we'll see what are the parts of the wind turbine and what are the types of wind turbine. If you look at the wind turbine, roughly we can say that, or mainly we can divide that into three parts. That is the foundation, the tower, and the turbine with the blades, with the generator, with the motor, with the air mechanism, with an nacelle. So basically, if you observe a wind turbine, so it is having a 3 parts, that is foundation and tower and the turbine, which we can call it head. So with the nacelle, with blades, with bearings, with the flow shaft, with the speed shaft, with the air mechanism, with the generator, with motor, with anemometer, with wind vane. So if you go to the foundation, what are the components? As I told you, first thing is the foundation. So without foundation, the tower cannot stand. Without tower, we cannot install the wind turbine and remaining parts. There will be a foundation with concrete, solid concrete assembly. Why? The foundation gives support to the wind turbine. The foundation gives support to the wind turbine. So it is a concrete assembly. Next, the tower. So with the support, with the help of the concrete foundation, the tower is going to stand. And the tower, it is made up of steel. It is a tube. It is a steel tube-like structure which raises the wind turbine to the height to rotate, to capture the wind potential. Next, the rotor blades on the rotor. So these blades are made up of reinforced plastic or glass fiber or carbon fiber. So these blades are needed to capture the potential of the wind, and because of these blades, the rotor is going to rotate. And the nacelle, which contains the main parts, yaw mechanism, the gearbox. If needed, we can turn the wind turbine to the direction of the wind. And low speed shaft, so which is connected to the rotor hub. Generally, that is going to rotate in low speed, and high speed shaft, which is going to connect to the generator. In between these two things, there is an important thing, that is gearbox, which will manage the low speed rotation to the high speed rotation, required high speed RPM of the generator. So these things are very important. Why there is need of air mechanics? See, the wind is going to blow with potential in certain direction for 1 hour. After 1 hour or 2 hours, it is going to change its direction of movement. It will change its direction of movement. So it is not convenient. At that direction, the wind turbine will not rotate at its ideal speed. So we have to change the direction of the wind turbine. We can change with the help of a mechanism. So here we'll be having a motor which will rotate the wind turbine and keep it facing the wind, even though it changes its direction. And sometimes we will change the angle of the blade also to capture maximum potential of the wind turbine, maximum potential of the wind. So if you are operating with this yaw mechanism which is facing the wind, normally the majority of the wind turbines will face the wind. So that is called the upwind mode of operation. So if you can operate a wind turbine in a upwind mode operation, we will get 20 to 30% of extra power. If you cannot operate at upwind mode, if you operate at downwind mode, you lose this benefit. Of course, you don't require additional installation cost of the motor. So, but we need more power. So that is very, very important. So next thing is that, so now we have discussed simply about different parts and their use in a wind turbine and their role in the wind turbine. And now we will see different types of so there will be a coupling, there will be a generator. Already I have told you a mechanism, anemometer, so which will tell you the speed of the wind, wind vane which will tell you the direction of the wind, the speed of the wind, the direction of the wind. If the speed is less, if the speed is more, then the capacity of the turbine, the capacity of the blades, we are going to decrease the speed, or we are going to stop with the help of the brakes. Anyway, there will be a controller which will collect the information from the anemometer and wind wave, and it will operate. It will change the direction with the help of motor. And there will be coupling between the main shaft and the transmission. So, as I told you, there is a gearbox which is important between this low speed shaft and high speed shaft. And we will see what are the different types of wind turbines. We can basically divide these types into vertical axis wind turbine and horizontal axis wind turbine. That means if the axis, if the shaft is parallel to the ground, to the earth, it is a horizontal axis wind turbine. If the shaft is perpendicular to the ground, it is vertical axis wind turbine. Again, in this horizontal axis and vertical axis, again there are different types of wind turbines. So first thing is that based on the number of the blades, we are going to divide here in the horizontal axis. So that is single blade. So if it is a single blade, it is cheap. It is the blade, weight of the blade is less. It can rotate at good speed, high speed. So, but it can cause the vibration problems and unconventional look. And if you operate at a two-blade mode, okay, it is somewhat better, almost like a single blade. So here also we'll get a stability problem. It is having good speed, but we cannot capture the entire maximum ideal potential of the wind. If you are operating at three-blade mode, so it will balance the gyroscopic forces. We can capture the ideal potential of the wind. If you go anywhere, if you see anything, any fan, which is made up, any fan, it will be having three blades, three wings. So if it is having three blades, only it can function at its ideal, at its max. That is the ideal operation. We can capture the maximum potential. So if you go to the more blades, again the efficiency decreases. If you go to the less blades, again the efficiency decreases. So the ideal operation is that with the three blades. But is the thing that we need a gearbox. So if you are increasing the number of blades, a number of wings, the speed is going to decrease. So to match the speed of the generator, we need a gearbox. We need additional cost, that is, of the gearbox. And that about the horizontal axis wind turbines. Next, we'll go to the vertical axis wind turbines. So, since from the starting, there is competition between horizontal axis and vertical axis. So, the horizontal axis wind turbine, heavy horizontal axis wind turbines with three blades are more popular than vertical axis wind turbines. Even in this vertical axis wind turbines, again from the starting there is competition between Darius and Savanius types of wind turbines. So the shaft is, the axis is perpendicular to the ground here. So the benefit of the Darius wind turbine is that it is having very good efficiency. It produces good torque, but it's economical, but it is not self-starting. It requires some external support for turning. We have to turn it with the help of some external support. If you come to the case of Savanius type of wind turbines, yes, it is less efficient than the Darius, but it is self-starting and it is highly reliable. It is highly reliable. And also, based on the capacity of power they are generating, we can divide the wind turbines into small wind turbines, intermediate wind turbines, and large wind turbines. The small wind turbines are the turbines with a capacity less than 10 kilowatts. So these we are going to use in the remote areas, in house, in farms, and for water pumping. And if you go to the intermediate, their capacity is from 10 to 250 kilowatts. So these are capable of supplying for a village, for a hybrid system, for distributed power. And the large wind turbines ranging from 250 to 2 plus megawatt of power generating capacity. And we'll connect these things to the central distribution power, central station wind farms. You can observe in this diagram that with the increase of the tower height, with the increase of the diameter of the blades, the power is also, the capacity of generating the power is also proportionally increasing. It is also proportionally increasing. So there varies the capacity of power. So the diameter, the rotor diameter, and the height of the tower. And also we can divide the wind turbines into offshore wind turbines and onshore wind turbines. So these offshore wind turbines are installed in the sea. So there we are having more potential than the land, less environmental disturbance, less wildlife disturbance, and also if we have to install heavy turbines, we can transport more easily in water when compared to the land. So the amount of power generated in the offshore is more, and the cost is also more because they are very, very huge wind turbines. So here the amount of cost is less and the capacity of production is less, and also the cost is less because small size of wind turbines we are using here when compared to the offshore wind turbines. Thank you for listening. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.